Hello, everyone. I think I can start now. I am Heloisa Carbone. I'm from São Paulo, Brazil, and I'm also a software engineering at Nubank, which is a fintech, a Brazilian fintech that uses Clojure as its first language. And today I brought this amazing topic that has been part of my life for the past 2 years to talk a little bit. So let's discover a little bit about the advantages of functional programming with Clojure. And to start in introducing this topic, I would like to share a little reminders about paradigms with you. Because to truly understand what functional programming is, it is better in this way. So what are the programming paradigms that we have today, right? The paradigms are different approaches that we create to solve a problem. So sometimes we have like different implementation problems that we want to solve in different ways, and sometimes we choose different paradigms to do that. And we have many paradigms. So we have two big groups, which are the imperative paradigms and the declarative paradigms. And the famous paradigms that we are used to are inside the group of the imperative paradigms, which are the procedural paradigm, object-oriented paradigm, parallel paradigm, and many others. But in the other hand, we have this group of declarative paradigms in which you have only three types of paradigms, which are the logic, the functional, and the database. And what is the difference between those two groups, right? I think that we can, to understand clearly what this means, is like imperative programming is like how you do something, and declarative programming is more like what you do. The imperative programming, it's more used among the industry, among the university course. Everyone might have like some contact with those paradigms more easily. So you have like access in any place that you want. But on declarative paradigms, this is something that you should probably seek to find it. It's not so common to have it around. And the functional programming is inside this declarative. But to truly exemplify how those imperative versus declarative programming works, we can think about a real situation. So imagine that you are going to your friend's house and you ask her address. And then if she answers you in declarative mode, she would say, oh, I live at XYB Street, and that's it. She just gave you an address, and you like do in any way that you want to get there. But in imperative mode, she would say to you like that, oh, leave your house and then get the first street for 4 blocks and turn right on McDonald's and right for 3 more blocks, and then my house is going to be on left. So she gave you step by step what should you do to get there, not only give you a destiny. And this is not like all the difference that those two paradigms, that those two groups have, but this is like a good exemplification of how they work, how they line of thought work. And we have like many paradigms, as I mentioned, and we have an evolution of them. So they were created and changed over time. And here I brought the functional programming paradigm and the object-oriented paradigm, which is the famous one nowadays. I think it's the most famous, if I have to say. And if we imagine object-oriented is like younger than the functional programming, and sometimes we not even have heard about the functional programming. We just like started to hear about it in recent years, and it's like it was created in the 50s, so it's much older and has been used mostly at the academy. And here I brought as well the comparison between the two groups of the imperative and the declarative. The imperative was created first, what makes sense, because if we imagine that the machine language were created in the beginning and they were like step-by-step rules of how to run the machine, it makes totally sense that to be the start of the imperative programming. But the declarative programming was created when functional programming started to be. And as I mentioned, the paradigms are created to solve problems. So we create those approaches to try to solve something that was generated by other things. And sometimes we have like some problems that are created by the imperative programming paradigms that the functional programming tries to solve. So what are those problems that we have? So the first thing in the imperative paradigms is that it's difficult to create relevant tests that guarantee reliability. So it's really difficult to test sometimes, and also to debug, because we have like some problems that happen that we are not able to reproduce and try to identify it, mostly because we have many mutable variables. So sometimes we declare a variable at one place of the code, and in the other we change the same value to other value, and this is something that we don't have like much control. And we even use sometimes those mutable variables as conditions to keep our code running. So sometimes we open a connection to a database or to a socket, and we rely on this connection to keep our code running. And this is not something that we can like control. So if this like close the connection, we lose totally control and some side effects happen. So we have like many things that go outside of our code. So throwing errors would be a side effect in this case, and it's really difficult to predict. And we want to avoid all those problems. We want to try to solve it with functional programming. So functional programming has many guidelines and concepts of implementation that help us to solve those outrageous problems. And we have some concepts here that we try to seek with functional programming. And the first thing that we want with functional programming is to have immutability. So all data should be unchangeable. I cannot create a variable here and modify it lately. So I am only going to be able to read this variable, but I'm not going to be able to modify it. And this is like the main group of functional programming. All the programming languages that apply functional programming try to follow that. And the immutability as well is a safe characteristic to prevent concurrence problems. So it's something that is really useful for us. And not only that, but as the name states, functional programming, we want to have our code based on functions. So we want to have functions first. So we need to start thinking about functions that can help us and that are much easier to test. So we want to have like small and direct functions that we are able to test. So we want to have pure functions. And pure functions are functions that we are able to predict what they are going to result. So for example, if I have an addition, always it's going to be 1 plus 2, it's always going to result in a 3. So I'm able to predict that. So that's okay, that's what I want. And with functional programming, we want to have function composition as well. So if we want to create as many functions as we can, and we need to be able to use functions inside functions. So for example, if I have a subtraction here, my subtraction could be a composition of other additional functions. Don't be scared. Those are some examples of Clojure. I will explain for you later, but just to exemplify those ideas of functional programming, I'm bringing them now. And other thing that functional programming seeks is recursion over loops, so to iterate data. And also we prefer expressions over statements because expressions can be predicted. We are able to predict what they are going to result. And if you run them as many times as you can, they are always going to result in the same value. What is different from the statements, which are functions that do not return any value and only generate side effects. And what we try to avoid the most in functional programming are shared states, which are the global variables that we use over time. So we don't want to rely on a connection, for example, that was created and open at some place on the code. So we try to avoid those kind of things. And also we try to avoid the side effects. And I mentioned this word a lot, but I didn't explain exact what the side effects are, right? Side effects are everything that go outside your function. So for example, an error being thrown is a side effect. A print to my terminal is a side effect. A connection to a database, an update, and many other things that go outside your functions are side effects. I cannot say that we do not use side effects in any situation. Of course, sometimes we need to connect to a database, we need to update things and everything. So we try to do it in a concise way. So we create small functions that will only do those things, that we only send those side effects. So we have like control over the whole thing. And I know that all these concepts are quite different than what we are used to. And we need to change our mindset to truly understand functional programming and to starting to think of how to transform data to achieve what is needed instead of change the variable over time. So transformation is the key to a well-written functional programming code. And functional programming has many programming languages that implement it and that are able to accept or even were built with the functional programming in mind. And here I brought some examples. For example, Java, which is an object-oriented programming language, and I think it's the most used nowadays by all the industry and in the courses and universities. And this language, after the release of Java 8, it also accepts functional programming as the lambda function. So we are able to program in both approaches at the same time. And also we have script, which is a multi-paradigm programming language and also accepts functional programming pretty well. So what I want to say to you at that is that programming paradigms is not like opposites. They are not, if you choose to use one, you cannot use the other. No, you can use them alongside each other and take the best of them for your needs. And with that said, we had like some other programming languages that were built with the idea of functional programming in mind. So all their concepts or all their structure is based on functional programming. And I brought 3 examples here, which is the Haskell language, which is a general purpose language, and it's highly used by Facebook, and also Lisp, which is the first functional programming language created. And this is the language that was created in the 50s. And it has an interesting history that it was a student that created, a student of MIT, and he was doing a research about artificial intelligence project. And he needed a programming language that could be able to process lists of data, but he didn't have at the time. So he decided to create Lisp to do this for him. And all the idea that he used, all the mathematical things he tried to implement on this function, on this programming language. And he created with that, and it was like really acceptable for everyone, mostly in the academy. And many other programming languages were created based on the dialect of Lisp. And Clojure is one of those programming languages that were created with the dialect of Lisp. And now that I mentioned Clojure, let's dive deep in this programming language that I brought today. And to start, I would like to tell you a little bit about its history. So Clojure was created in 2005, but it was only released in 2007. And it was created to be designed as a general purpose language, a practical functional language that would be suitable for use by professionals, wherever its host language was Java, for example. And Rich Hickey was the creator, and a fun fact is that he created this language in his sabbatical period of his life as a personal project that could revolutionize the tech industry, not only the academy. So he built Clojure to be a functional programming language that could be used in huge services, in huge industry. And he built it on the top of the JVM, which is the Java Virtual Machine. And this allows and gives the benefits of functional programming on whatever platform you like, because we have like access to the JVM from our computers, from our cell phones and everything. So it's a simple way of programming doing as this. And as we know, the JVM is also, as a platform, is also became a stable base for building large software systems on top of it. So it was like easier and accessible for anyone that wanted to try. And not only that, but Clojure is also an open source language and has interoperability with all the libraries and frameworks of Java. And as I mentioned before, has the Lisp dialect. And what it means to have the Lisp dialect. I mentioned at the beginning that Lisp was created to be a language that could process lists of data. So imagine that all the structure of this dialect is based on lists represented by parentheses. So this is like an interesting characteristic of Clojure and all those Lisp dialect languages, which is they are based on parentheses. So everything is about parentheses. I even brought this comic strip that says, "These are your father's parentheses, elegant weapons for a more civilized age." So everything is about parentheses. I know that is scary when you look at that, but don't worry, it's quite simple. And if you understand what those parentheses does in a simple way, you're going to see that everything that comes after it is quite easy. And here, let's discover how this parentheses work. So this is like the main and most important thing in Clojure. Those parentheses with a function name and arguments. This is our declaration that will be followed in all the code, in everything, and what they represent, right? Those parentheses are lists, but they are also invocations. So imagine that when you have those parentheses, they are calling a function, or they are trying to apply something on those arguments. And this function name could be a symbol or a string. A symbol would be similar to the addition that I showed earlier, but the string would be like the declaration of a function around the codes that you invoke here. And my arguments are numbers, strings, lists, other functions, in any number that we need. So we can decide to have like as many arguments as is necessary. And here I have like some examples that I showed early, the addition. So here I can see that I have my parentheses, then I have my addition symbol, and then I have 1 and 2 being my arguments. And I know that these parentheses are invoking the application of these arguments to my symbol plus. So 1 plus 2 is equals 3. And the other example of the function composition, we can see that we have other functions as arguments. So I have as well my invocation of the function, my plus symbol, and then I have a function which is a subtraction with the same idea of I have my minus symbol with 2 and 1 being the arguments, and then I have other addition, and all this results in a 3 as well. So don't worry, I know that this is different, but it's quite similar, and it will be like that till the end. So everything that you see in Clojure will have this structure. And Clojure has a strong data structure. So those are some things that we have. So we apply immutability all the time. This is like the first rule that I mentioned about functional programming, and we use it like all the time. So we do not like modify our variables. All the time that we create or edit a variable, we are actually creating one. So our variables are only able to be readable. They are not able to be modified. And we support equality semantics, so we are able to compare variables, to compare values. And also we have lists, as I mentioned, so we have collections, and they can be manipulated and iterated over time. Clojure relies on types and has a huge number of data types. So similar to Java, we have string, we have numbers, we have lists, we have symbols, which is not so used in other programming languages, but in Clojure it's highly used and is represented by 2 dots and a string name. For example, here I have 2 dots, hey, I am a symbol. This is quite used to be a key value in a map, and also to be an enum. And so this is highly used since day one. And also, Clojure has dynamic typing, so it does not verify types during compilation. It only does at runtime, and it's also a home iconic language. I know that is a weird word, and in the past I hadn't heard it before, but this means that all the code that we have is actually data. So everything that you implement in Clojure is data. So we have this home iconicity implemented. And with all that said, I came to this topic of macros. Macros are something that we have in Clojure that is stronger than in the other languages. So this in Clojure is a simple thing that we use all the time. It's not something that you need to be like a senior programmer to start using as it is in other languages. So this helps us to modify the code and extend to our needs. So we do as we want. So we create things that will help us to achieve something. And this is because our code is all data. So this home iconicity allows us to have that. And Clojure has many built-in functionality that are macros actually, and they are based on built-in functionalities in the all. So here I have an example. I have the when condition that we have in Clojure. This condition is highly used. So the representation of this is like, when something happens, I'm going to do this. And this is a macro that already comes with Clojure. And if we see the implementation of it, it's actually an if with a do. And we have many other macros. I even introduced this topic because I want to talk with you about an interesting and really useful macro that we have that helps us to have the transformation idea. I brought this word before, and I said to you that this is the key to a well-written programming language code with functional programming in mind. And with this idea of macros, we have a macro that helps us to do that. And to show you this and some other things about Clojure, I brought a case study that will help us to truly identify what's happening and why they are used and why they should be used. So here I have a variable. So this is how I declare a variable in Clojure. Def, the name of my variable, which is case stud, and my array of people. So here we can see that each people has a name, which is a symbol with a string value, and an age, which is also a symbol with a number value. And let's imagine that this is all stored in a database, and we want to do some stuff with this array. So the first thing that we want to do is to add a new attribute profession to each element of this list of people. And after that, we want to update this new list to my database. And finally, I want to be able to filter everyone that is older than 21. So if I put it in words or in programming style, I would do something like that. So I would have my case stud, then I would add profession to list, then I would update people with profession, and finally I would filter people over 21. And this is actually something in Clojure. This single arrow is a macro. It's a threading macro in Clojure that allows us to do it in a simple way of reading what you need to do exactly. So in thread, we have two types, the thread first and the thread last. The thread first is this one that I showed you with the single arrow, and the thread last is this other with the double arrow. And what those two threading macros will retrieve to us. So imagine that those things are being applied to our case stud. And after I run all of that, I will have this result. I will have only people that are older than 21 with their new attribute profession being displayed. But let's truly understand what they are doing, because it's going to be easier to understand. So in thread first, I put my single arrow as being the first parameter of my parenthesis, as you can see. So it's the symbol or the function that's going to be applied. And then my second parameter is the case stud, which could be a string, a number, but here is my list of people. And this is passed as first parameter of my next function. And all those functions that follow, add profession to list, update people with profession, filter people over 21, are functions that are declared around the code, and they only have one argument to receive something. And here, the first add profession to list is receiving a list. So I am receiving the case stud as my first parameter here. And we know that this function retrieves another list that is passed to the next function as first parameter as well, and the same to the last one. So this is what thread first does. It passes the argument, the value, the variable, as first parameter to next function in sequence. And the thread last does the same, but passing this variable as last parameter, not as first. So here I have in the sequence a map in my thread last. And this map are to a for each, if you can compare with other languages. So it's going to iterate over my list, and it's going to apply a function, which is the add profession function, to each element of this array. And after that, it will retrieve other lists. So this is a built-in functionality of Clojure. I know that many other programming languages has this implementation of map, but this is the idea. And as I showed you in the thread first, the update people with profession only have one argument. So this argument could be the first or the last. So it's going to receive the same list here. And finally, it's going to retrieve other lists that's going to be passed to this filter. And the filter is similar to the map. So it's going to iterate over each element of this list, and it's going to apply a predicate. So it's going to check if this person that has been analyzed is older than 21. And here we see that we have like a different implementation of a function. So this is how we create an anonymous function. So instead of creating a declaration outside my code here, I decided to create an anonymous function that would call other function that was already created. So this declaration of sharp with parentheses is an anonymous function. So it is an invocation. And inside it, I have this over 21, which is a function that is declared in my code. And it only receives one element, which is a number. And here we have other interesting invocation, other interesting parentheses with a symbol and a percentage. The symbol is the 2.8 that we saw. That's something that we have in our case stud. And this percentage represents each element that's going to be iterated. So here I am saying that this element that I'm iterated is only going to retrieve to me the value of age. So I'm only passing to this over 21 the value 18. And this is how I check this anonymous function. This is how it works. So apart from the threading macros, this is something in Clojure really useful that you can use like in many situations. And now that we understand what those macros are doing, let's see the implementation of those functions that they are calling. So I'm going to start with the thread last functions because they are pure functions. And here I have the add profession, which is the one that we use on map. So DFN is how I declare a function in Clojure. And then I have the name of my function, which is the add profession, the number of arguments that I have. So here I receive person as my argument. And if we check in our case study, it would be one of the elements of the list. So for example, name Anna with age 22. And in this implementation, I declare a variable inside my function. And this let profession, software engineering, it's how I declare a variable inside a function, not like outside. The DAF that I showed you early, it's more like a global thing. And so here I'm declaring a profession with the symbol software engineering. And in the last line, I'm associating this value to my person. So I'm adding this attribute to my person. So I will have something like that. So I have my name, age, and the profession with software engineering. And in Clojure, we do not need to put any return statement to say that we are returning something. The last thing that you do in a function, it's what's going to be retrieved. So here we are retrieving this new map with this new attribute profession. And after that, we had the update people with profession, which is the function that will store our new list database. I didn't put it here because it's not necessary. I just wanted to show something really interesting here, which is this exclamation mark. And exclamation mark represents that this function will generate side effects. So as updating something at database is a side effect, I declare as a code convention in Clojure that this function is doing that. So here I just return the same list, but it's actually a new list of people. But that's what this function do. And finally, the over 21 function is the function that's going to check if the age that has been passed is greater than 21. And here we have a question mark. And the question mark, as well the exclamation mark, represents that a Boolean will be retrieved. So it has a meaning. It is also a count convention in Clojure. And it states for us that it only retrieves a Boolean. And now we are able to truly understand what this thread last is doing. So I have my case stud, and I'm going to map each element of my list to add profession, and then I'm going to update people with profession, and finally I'm going to filter people that are older than 21. And the thread first functions are a bit different. So here I have the add profession to list, which receives all the list, all the people, so it receives people, and applies the same map that I did in the thread last. So map add profession, so it uses the other function to each people of this list. So what I did was to put all implementations in a new function. And we also have the filter people over 21, which it does exactly the same of the filter in the previous one. So here I'm receiving all the list of people and I'm doing this filter. So it's going to iterate over each one of these people and we'll find who is older than 21 as well. So now we are able to understand what the thread first did here. So I received my case stud, then I add profession to list, then I update people with profession, and finally I filter people over 21. So this is the case that I brought. I think this is a better way to exemplify and show you some stuff with Clojure, because I know that it's really difficult to understand what everything does. And sometimes with an example, it's much easier what they are actually doing. So I think a case stud is a better approach to do that. And with all that said, I want to say that Clojure is a special programming language, and it has an accelerated learning curve. So I can say by experience that everyone that starts using Clojure and starts coding in Clojure has a fast growth in knowledge. So in a week, you're able to create something from zero and has a good experience. So it is a good programming language to start if you want to learn a functional programming language. And it's all mostly because it has a simple grammar. It might look a bit weird because we have like so many parentheses and we are not used to that, but it's all about parentheses. And if you understand clearly well about the invocations, name of the function or symbol, and arguments, you're able to predict everything that's going to be done in a code. So you are able to read and understand what it's being done. So it's easier. So it has really a simple grammar. And not only that, but Clojure has a great community, which is really collaborative and helpful. And you are able like to connect with them and give feedbacks and try to share ideas of things that could be implemented. And they are all well acceptable, and they want to have those approaches. Clojure is not like a language that has many Stack Overflow questions answered, so it's difficult to find a specific doubt, but the documentation is really good. So because in the documentation, you have the explanations, of course, but you have many examples because the community helps to do it. It puts examples of how you can implement something, of how can you use something. So you have like many examples that help you to understand and start coding. And if I could like give a thing that where to start in Clojure, I would recommend a book that is the Clojure for the Brave and True, which is a super fantastic book. It's truly didactic and has like an awesome way of teaching. It's like a Clojure fairy tale actually, and it's really useful for you like to start understanding what everything does. So it's pretty good. If I could recommend, I would say start reading this book because it's going to be a good reading, and also it will teach you a lot. And with all that said about Clojure, I want to say for you to make Clojure be ever in your favor and functional programming in your life. I hope you had enjoyed it and learned a little bit. You can find me on social medias by Heloisa Carbone. And if you have doubts, concerns, feedbacks, just you can send to me and I will be delighted to answer to you. And now I would like to open for a few questions if you have, but because we still have a few minutes, so I will check if you have some questions in the chat and then I can answer you. And thank you very much. We have like a question that says, when macro seems very similar to imperative programming. Yes, it is something I wanted to show to you, mostly because this threading macro is something that brings us to this idea that we are used to about programming. So this idea of putting line to line of thought, because in a normal way of programming, if we do not use threadings that I showed you, we would have like many parentheses inside parentheses. So imagine that instead of I have like that line of thought, I would have my filter first, and then inside my filter I would have the call to the database, and inside the call of the database I would have my map. So it would be really confusing, because this is the way of thinking in Clojure and in functional programming. But this threading macro allows us to make it easier and try to put it in a easier way for us to read the code. It's even better for us to try to identify problems and check things, because sometimes if we do not use the threading macros, it's really difficult to put it like in words what's happening, because you lose control of the parentheses. They are quite amazing, but they sometimes you don't know where the parentheses close. We even use some tools that help us to identify the parentheses, that put all the parentheses in colorful mode, because then you're able to see where the parentheses close. But the threading macros allows us to do it in more imperative mode, so it's better. Oh, thank you. Someone said that liked my examples and analogies. Thank you very much. I try to put like in a more real situation way, because it's easier to understand. I know that this topic, it's a bit confusing and a bit different than what we are used. So I think that's a great way of doing. So thank you very much. I think we don't have like more questions, but I'm open. If you have like questions in the future, just contact me. That I would be delighted to answer you. And thank you very much to being here today with me. Thank you.